Hello guys, and welcome to the basics 2 of Web3 Learns Solidity cohort. And in this portion, we will be looking at a problem statement. The problem statement states that there are two addresses that are statically defined, and and we need to create a function so that these addresses can receive or can withdraw one ether at a time, and they can withdraw only half of the total amount so that everything is equally distributed. Means if there are 10 ethers stored in a smart contract, then these two externally owned account will be able to withdraw 5 ethers each. Now let's just look at the solutions. First we will look at on a paper, and then we will start creating the smart contract and we will start improving it. We will look at the flaws, and we will look at what mistakes we make in the beginning so that you don't make. I mean, you have to make mistakes in order to learn, but we will be making mistakes together so that we learn together. And the first step is to statically define two externally owned account. And what we are going to do is we will take help of the Remix's virtual machines account. They are predefined in Remix, so we will use the second and third account as Ram and Leela respectively. And the first step is complete. The second step is a way to send money to the contract. We need to send 10 ethers to the contract, 10 ethers, so that these two externally owned account can withdraw money. Else where will the money come from? Magically from thin air or something like that? Nothing. And then we need a way to send money from the contract to Ram and Leela, means the externally owned account. So I want you to try it on your own, but I'm pretty sure if you are a complete beginner, you won't be able to do it. But if you have some experience in Solidity, then it might be a piece of cake for you. But we all are beginners. So let's get straight into it. I have already statically defined the two addresses, Leela and Aran. And where do this address come from? I have just said it. I'm saying it again. It's from Remix's virtual machines account. And the first address is, I'm not using the first one, I'm using the second and the third one. As you can see, this corresponds to Leela, and the third address corresponds to Ram. And now what we have to do is create a function so that we can send 10 ethers. How to send ethers to a smart contract, I am pretty sure I have covered in the previous lecture in which I covered the payable stuff. So just recall, if you have not watched it, try watching it again, and let's create a function. That's it. And this is going to add money to the smart contract. In order to view the total amount of money, what we have to do is also create a function view contract. What do we have to do? Address of this statement means that this contract's address dot balance. So if you use dot balance, then the respective contract. So for example, if I write a Leela.balance, then it will show me the balance that Leela currently had. But I want to view the smart contracts' balance, so I will write address of this dot balance. So just for experiment purpose, let's try to deploy the smart contract and see. There is one mistake that I have done. Okay, I haven't written on it. There you go. I'm pretty sure everything is all good. And I deploy the smart contract, I check, and I add money. I convert it to ether, and I add 10 ethers to the smart contract. I click on this function. 6. I'm pretty sure something went wrong, and I instead of 10 ether, I somehow managed to give 6 ethers. As you can see, it's 6 ethers. It means 6 plus 18 zeros. So it means 6 ethers because this is in way. Now what I have to do is the second step or the third step, which is find a way. Where did it go? a way to send money from contract to Ram and Leela. Now this is a little bit tricky because there are three types of functions in which you can actually send money from a smart contract to a money means ether. Okay, in this context it is ether. So there are three ways in which you can send from a smart contract to another smart contract account or to an externally opened account, which is like call versus transfer versus send. I will go in detail in some other video or in the later part of this video. We will be now focusing on transfer. So if I write Leela.transfer, then what will happen is the amount of money that I specify in the brackets of transfer, if those amount exist in my smart contract, they will get transferred from this contract to Leela. See, it might not be very clear because I haven't done the coding right now, but just look at it and look at the mistakes that I'm going to make at this point of time. Function send public, send. Okay. Now instead of this, what I'm going to do, I'm just changing it to Leela. No, you know what? I'm going to copy this and I'm going to make another function so that we can view the contract balance of these two accounts, these two externally owned account in Ram and Leela respectively. Leela balance. Then what I'm gonna do? Leela dot balance. No mistakes. Now what I'm going to do is make Ram balance. Okay. There you go. Wait, what? Okay, Ram. Everything is all good. Now I need to send money to Leela. How am I going to send? I'm just gonna write Leela. Wait, just look at it. Leela.transfer and 1 ether. You can actually specify the units Solidity itself. So it's 1 ether. You can write 1. If you just write 1, it will be, I guess, a standard, which is way. I'm writing 1 ether, so it means that 1 ether will be transferred from this contract to Leela. Means in this, according to this logic. But if I try to compile this, it will send me an error. Reason, there are two mistakes. A, this function is not payable. If you do not declare a function payable, then you cannot send or receive, or you cannot make money transactions from this function. So step A is, if any sort of transfer, send, function type of stuff is being done in a function, make sure you use payable. Okay, step 1. Step 2, there is something. Step 2 is Leela is not explicitly converted as payable. So if you want to send money to any sort of account, then first you have to declare the account as payable as well. Now this might not make sense, but I will just give you a quick follow-up, which is, if you want to send money to an externally owned account, then you have to make it payable. Okay, so make sure whenever you are trying to create a smart contract, make sure you think accordingly. So I have to write payable. Now, even if I try to save it, it will not work. It will show me an error. Let me show you the error. The error is, it is not implicitly converted to address payable. So what I have to do is make it payable. There you go. Okay. Leela draw transfer. There is some error, which is transferor available, address payable. I haven't compiled it, right? Oh, okay. I converted it to Ram. Okay. I need to make Ram as well. Leela as well. And now both of these contracts are good to go for money transfer. As you can see, the contract is successfully compiled. And am I missing something? Now I can view Ram's balance. I can view Leela's balance. So just like I've created something for Leela, let's just create something for Ram as well. No, why discriminate? Seems good. Sounds good. Okay. Now what I'm going to do is deploy the smart contract. So after deploying the smart contract, what I'm going to do is add some ether, which is from the deployer account, which is the 0th account, and the first and second are Ram and Leela respectively, or you can say second and third, however you want to interpret. It's always the same in Remix. So I'm going to send 10 ether, and I'm going to add money. I don't know, I just wrote 10 and it sent 6 ether. It doesn't matter. Let me add 4 more. Let me add 4 more ether and add money. 2 ether got okay again. Yeah. So let me check the balance of this contract. View contract balance. It is 10 ethers, which is 10 plus 18 zeros, and Leela's balance is 100 ether because it's standard. These both have 100 ethers, and Ram's balance is also 100 ether. If I click on send money to Leela, the Leela's balance will be 101 ether. If I send money to Ram, then Ram's balance will be 101 ether. Now what I want to do is put some restriction that only that Ram will be able to withdraw only 5 ethers and Leela will be able to withdraw 5 ethers. So what, in order to do that, we have to learn about a require statement, or else you can also use the if else statement, which will be a better thing, but let's learn about this require statement. It works just like if else statement. So require, require. Then here in the first place I'm just writing blank so that you can understand. So in this blank you have to write the condition. For example, I will write here that if the balance of the not the balance of the money transferred to Leela less than equal to 5, something like that. Okay. How am I going to keep track of the money transfer to Leela? Of course, I will be keeping track of how many times Leela has transferred 1 ether from the smart contract. So I'll create 2 state variables, one for Ram, one for Leela, and they will start from index 0. Every time I press on that button and transfer 1 ether, the count will be incremented. So I have written require Leela money less than equal to 4. Why I have written less than equal to 4? Because I'm starting from index 0. So 0, 1, 2, 3, 4. The total count will be 5, of course. So I have written Leela less than equal to 4, or you can also write if Leela money less than 5. Okay, same thing. So equal to 4, and what I'm going to do is increment the count of Leela money from 0 to 1. So Leela money plus equal to 1, which is also equal to Leela money plus 1, which is also equal to Leela money plus. Okay, so I will, okay, just let's keep it like this, and I'm going to, no, I'm not going to copy paste, I'm going to make it Ram money plus. Okay, now I'm going to save the smart contract or compile the smart contract, and I'm going to deploy it. Okay, so instead of V, I'm going to make it ether, and I'm going to did I deploy this? No, I didn't deploy. I deployed this, and now I'm going to transfer 10 ether. Think good. I added 10 ether, and let's check the contract balance. Contract balance is 10 ethers, and Leela's balance is 100 ethers. Ram's balance is also 100 ether. Every time I try to click this, I'm going to transact money to Leela. Okay, now let's check Leela's balance. It's 101 ether. I'll again try this. It's 102 ethers. I'll again try this. 103 ethers. 104 ether, and I'll try to do this one more time, and it is 105 ethers. Let me try to transact it once again. Let me just open this up, and as you can see, the transaction got reverted. The reason being transaction because money withdraw exceeded. So Leela can not increment this or increment her money. She cannot withdraw more money now, but Ram can withdraw more money. Wait, what? Sorry, send to Ram. Yeah, see, 1, send Ram, Ram. Now 104, and I will do it once more. So as you can see, each of them has 105. Now even if I try to send any of them, the contract has 0 ethers, so it has no money. We have successfully completed first challenge. To make some changes in the smart contract, but before that I want you to learn about this message.sender and this origin stuff. And so for that, imagine that there is a smart contract named bank and it has a function A, and when Ram is going to call this A function, then the message.sender, okay, the sender of the message is going to be Ram, and the origin of the transaction is also going to be Ram. Now what is the difference between these two? So suppose there is a smart contract named cont, 0x cont, and it's the address, 0x cont is the address, and Ram's address is 0x Ram, and Ram's calling function B, which in turn calling function A. Okay, so what do you think the message.sender of this function A of bank going to be? It is going to be the address of the smart contract that is calling this function, which is 0x cont, and the origin of the transaction is going to be 0x Ram. Okay, so this is what I was trying to say, and I guess I have not introduced you to something known as constructor. Constructor is a special function that is triggered only once and during the start of a contract. Okay, so the problem statement lies here is, what if the deployer of the smart contract, okay, transfers 15 ethers to the contract, okay, and Ram and Leela only can withdraw 5 ethers each. Okay, so it means that 5 plus 5 10, and 15 minus 10 is equal to 5. So there is 5 ethers that is permanently locked in the smart contract. There is no way we can remove the 5 ethers because we haven't created any function for it. So what do we have to do? We need to create a function that will transfer the rest of the ether, or that will transfer the total number of ethers that is present in the smart contract to the deployer of the smart contract. And there is only one constructor without any parameters. Your assignment is going to be set Leela and Ram as through parameters in this constructor. Now what I'm going to do is I'm going to make owner equal to message.sender. Okay, now it's going to show an error. Why? Because I haven't casted it. Table. Okay. Now in order to test it, what I'm going to do, I'm going to write a function that will transfer. Function transfer funct funds 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 public payable, and I am going to transfer the money to to the owner dot transfer, and I'm going address of this dot balance. Okay, there you go. We have to check if now I guess there is no point in checking in this case, because eventually we will be transferring the money to the owner. So doesn't matter who creates this transaction, the money is eventually going to be transferred to the owner. Moving on to the next challenge, what I want to explain is mapping. Mapping is a data structure of a key value pair, I would say, and suppose you are creating a address to uint mapping. Mapping can be of any time, address to uint, uint to boolean, anything that you can also create custom data types, and you can create a mapping for that as well, and address to uint, and I name it as mp. Okay, mp, and I set the mp value of 0xpri as 10. So whenever I will call the mp, whenever I call mp mapping with the value as 0xpri address, which is my address, it will return me 10. Okay, let me show you by this example. So there is a function that returns the value of this mp mapping. Okay, and here it is the message.sender. So when the message.sender is 0xpri, what do you think the value is going to be? Think, it's going to be 10, right? So suppose Ram calls this mapping or this function. What do you think the value is going to be? It's going to be nothing. It's going to be the default value of uint, which is 0. Oh, yeah, 0. So I hope that you understand this. And now the case is, or the problem statement here is, I don't know how many people are in the family. Okay, I have no idea how many people are in the family, how many so the problem statement is, I have no idea how many people are there in family. There can be Ram, there can be Leela, there can be Sham, there can be Radha, there can be so many people. So is it feasible, or is it even practical to create these many types of state variables, or these many amount of state variables, and then in order to keep track we also have to create their corresponding uint or integer in order to keep track of how much money they have withdrawn? Is that practical? No. So what we will do is we create a mapping of address to uint type. Why? So that we are creating this mapping so that every single person who is withdrawing will have a uint mapping, and we will increment it by +1 after every time he triggers the function, right? He or she triggers the function. So let's I want you to try this on your own and consider it as a challenge, and now I will be doing it myself. Alright, so let's get started with the solution. So what I have to do is create a mapping from address to uint. So let's do it. That's how you declare a mapping, and this name is going to I'm making it public so that automatically your function gets created, and the name is going to be what? MP, I guess. No, okay, doesn't matter, the name doesn't matter. And what do I have to do next is create a function that will return the balance of message.sender. Okay, function get balance. Look at the amount of mosquitoes, dude. Public view returns uint message.sender I'm going to do is first make a condition check, I guess. Okay, I'm leaving that uncomment, and I will do it later. I am going to make message.sender.transfer. I'm going to just write the condition check require mp of message.sender less than equal to 4, else enough boy. And I'll just make it mp of message.sender plus equal to 1. Now I'm assuming that this looks good. 10 ethers got transferred, and what I have to do is call this function get balance. As you can see, the money it is returning me the balance of this address, which is 89.99. If I change it to this address, what it is going to return it is going to return the
Yeah, it should show 100 ethers, but it is showing 99.999997000 ethers. The reason being Remix sucks, and stop using Remix and start using Ardent.
Now I will be triggering this function by this account, which is the second index, which is the third account, and I will be clicking on this transfer money to sender. It works. 1 2 3 4, and let me see the balance, which is like 103,999, which is equal to 104, and I will click it once more, so it will be 105. Okay, now I'm going to check on get balance. So I have checked it. Now I will click on it once again. As you can see, the transaction did not get succeeded, and now what I'm going to do is change to another account, and I will click on this transfer money function. Yeah, and now the contract enough boy, and plus the contract doesn't even have much money to send with. What I'm going to do is check how many times I have clicked the button, which is 5 fault value. It is 0. Alright, so what's the problem? There is no problem, but what if there are like 15 ethers in account and Alice and Bob? There are two accounts, Alice and Bob. What if Alice clicks on another account and disguises herself as someone else and tries to withdraw more money, but she should be able to only withdraw 5 ether, but she creates another account and tries to click on this function, and so by this method she will be able to withdraw more than 5 ether. Why? Because she has 2 accounts now. So how are we going to tackle this? So in order to do that, what we can do is we can create a function that can be only triggered by the owner, and that will verify. Okay, Alice in the beginning will tell the owner, hey, this is my account, and I will only call the function from this account, and I do not have any other account. So owner will say, okay, hey Alice, I am marking you as true, and I am whitelisting you, and only you will be able to trigger this function. Same goes with Bob. Okay, and same goes with almost every single account that will be whitelisted by the owner. So for that, what we have to do is create a mapping from address to boolean whitelist. Okay, and this function, and we need to create a function whitelist in order to whitelist, and that can be only triggered by the owner. I'll check it by require message dot sender equal to owner, because if you remember, we already set the deployer of the contract as our owner, not authorized. And the next part, what we will do is we will whitelist Alice, and now in the parameter I will give a parameter on whom to whitelist. I have named the variable a very long stuff so that you can understand what I'm trying to do here. Account to be whitelisted by the owner, and here the owner will send an account, and that will be whitelisted. Alright, now the owner now only the owner can trigger this function, and only the owner can authorize this. Now when we are transferring money to the sender, what we have to check here is require message.sender. Now what we have to do is require whitelist of message.sender is equal to true, not authorized. Sounds good. If the message.sender is whitelisted, only he or she will be able to withdraw funds. Apart from that, no one should be able to withdraw funds. Sounds good? Yeah, so let's just test this contract, and I guess this will be the last part before I teach you some new concepts. I'm I'm pretty sure that you might be having some doubts, so for that please join the AMA session. Okay, so what I'm going to do is take so what I will be doing is whitelisting these two addresses. So I will be on this first account, and I will take this account, copy this account, and I will go back to this account. And what I'm going to do is, I did a mistake earlier, I'm going to whitelist it. As you can see, it has been whitelisted. How to check if it is whitelisted or not? Just click on, verify it from here, whitelisted. As you can see, it is true. But if I go and check on any other random address and I will check, it will be false, because the default value of boolean in Solidity is false. Yeah, I whitelisted this account, so this account is good to go, and I guess I can withdraw money from this account. Transfer money. Let me check. Transfer money to sender. You can see, as you can see, the transaction was successful. 1 2 3 4 5, and after that I won't be able to withdraw money. Let me check the balance, which is like 105 ethers. So what I was saying is, it's better to make a check here, or else anyone will be able to break the functionality of the smart contract by calling this function. So I will also write require owner equal to message dot sender. Yeah, not authorized. Alright.
Now I need to make sure that people withdraw only after a couple of time. The time I want to define is 10 seconds. In Solidity, we can define time as well in second, minutes, years, etc. So what I'm going to do is, I'm going to create a event time to withdraw, and I declare it as 10 seconds. And in order for me to allow each user to withdraw after 10 seconds from which he or she has withdrawn earlier, I need to create a mapping from address to event, and we call that timestamp. So mapping from address to event, and we call that timestamp, and let's make it public. And now what we have to do, as this, don't forget that we have to set the value of each mapping, else the value will be 0, because the initial value, and we do that where we whitelisted the account. During that time, we initialize each account with a timestamp. So timestamp block.timestamp is a global variable already given by Solidity. It is the time elapsed from the first block, to be specific. What do have to do is like timestamp, no, not this, of message, not message.sender, of this account, right? Because this is the account to be whitelisted, is equal to block.timestamp. Alright, and now let's do the condition check, which is here, transfer money to sender. What do I have to do here is, I need to check require if the block.timestamp that I'm checking at, block.timestamp minus the message.sender's timestamp, which is initialized here. So what I have to do is timestamp of message.sender. If it is initialized only, then it will have a timestamp, else the value will be 0. If it is not whitelisted, its value will be 0, and it will be reverted here itself, so you don't have to worry about that much. And if that is greater than or equal to 10 seconds, okay, not the value is of course an integer, so if it is greater than 10, then we will allow, else we will say that, hey boy, calm down, more to go. No, not okay, hey boy, calm down. Then what I have to do is set the timestamp from which it was initialized to the current timestamp, because this is the time when I withdrew the money. So timestamp of message.sender equal to block.timestamp. I guess we did it. No. MP plus of message.sender plus okay, no, I'm pretty sure I did not put a semicolon here. Yes, there you go, there you go. And very excited to deploy the contract. Let's do it. What I'm going to do is refresh it. No, let's deploy it. I deployed this, and now what? And I need to first whitelist. I'm going to whitelist the 6.1 account. Okay, it was whitelisted. Let's go to the 6.1 account, and now check the balance, which is yeah, stupid remix. Okay, now I'm going to click on transfer money, right? As you can see, it was successful. Now if I immediately click, it will, hey boy, calm down. I have to wait for some time. 7, 8, 9, 10. So you can see, I can do it again. It will say, hey boy, calm down.